Chemical properties of carbon compounds. All hydrocarbons, including natural gas, petroleum gas, diesel and kerosene, burn in air to produce carbon dioxide, water and a large amount of heat and light. Hydrocarbons react with oxygen to give carbon dioxide, water, heat and light. Hydrocarbons are efficient energy sources. These are therefore called fuels. The process of burning fuels in presence of air to produce heat and light is called combustion process. Combustion of fuels is basically an oxidation reaction as the carbon and hydrogen present in fuels take up oxygen from air to form carbon dioxide and water. The liberation of heat energy during combustion of fuels is generally used as such for heating purposes. The liberated heat energy during combustion of fuels is converted into mechanical energy by engines such as internal combustion engines and external combustion engines in motor vehicles. Combustion of carbon compounds. Carbon, in all its allotropic modifications, diamond, graphite and fullerenes, burns in oxygen to give carbon dioxide and liberate heat and light energy. Carbon in solid state reacts with oxygen in gaseous state to give carbon dioxide in gaseous state, water in liquid state, heat and light. Hydrocarbons. Both saturated and unsaturated hydrocarbons burn in oxygen to form carbon dioxide, water, heat energy and light energy. For example, methane burns in oxygen to form carbon dioxide, water, heat and light energy. CH4 reacts with O2 to give CO2 plus H2O plus heat and light. Compressed natural gas, that is CNG, used in buses is 90% methane, that is CH4. Butane, that is C4H10, is the main constituent of LPG, that is liquefied petroleum gas, which is used for cooking purposes. Butane burns in oxygen to give carbon dioxide, water, heat and light. Carbon, hydrogen and oxygen containing compounds like ethanol, that is C2H5OH, also burn in air to produce carbon dioxide, water, heat and light. Ethanol is sometimes used as a fuel. It is a mixture of 5% ethanol and 95% petrol. It is a cheaper and cleaner alternative to 100% petrol in motor vehicle. Burning characteristics of carbon compounds. A candle, when burned in air, produces yellow flame and a lot of black smoke. The yellow flame and black sooty smoke contain unburnt carbon particles. Yellow flame and black soot indicates compounds present in kerosene have undergone incomplete combustion of carbon compounds. If a fuel is burnt in insufficient quantity of oxygen, it burns with a yellow flame with black smoke. Incomplete combustion produces less heat energy. Proper combustion means complete burning of carbon present in the fuel in excess oxygen. Carbon-containing fuel plus insufficient quantity of oxygen gives yellow flame containing unburnt carbon particles. Carbon-containing fuel plus sufficient quantity of oxygen gives blue flame without any unburnt carbon particles. Have you noticed the burning of LPG gas in your household kitchen? You must have seen that the burners in the stove have a number of holes in it. These holes are inlets for air. When the LPG burns in air sucked in from the holes of the burner, it produces a blue flame. If somehow the holes of the burner are partially blocked, LPG burns with a yellow flame. This is because there is incomplete combustion of LPG as the supply of air is insufficient. Incomplete combustion produces yellow flame with less heat energy and also blackens the outer surface of utensils with unburnt carbon particles. This simply means that efficiency of LPG as a fuel is reduced. Difference in the burning characteristics of saturated and unsaturated hydrocarbons. If we compare the burning of a saturated hydrocarbon with the burning of an unsaturated hydrocarbon having same number of carbon atoms, we find that the saturated hydrocarbon burns with a more clean blue flame in comparison to unsaturated hydrocarbon. Example: C2H6, that is ethane, burns with a more clean blue flame. C2H4, that is ethene, burns with a more yellow sooty flame. C2H2, that is ethyne, burns with a more yellow and more sooty flame. If you check the formulae of C2H6, C2H4, C2H2, you will find that the carbon content increases in the order. C2H6 has lesser number of carbon atoms as compared to C2H4, and C2H2 has lesser number of carbon atoms as compared to C2H6 and C2H4. Some substances burn with flame and some substances burn without a flame. Petrol, ethanol, candle wax and cooking gas, that is liquefied petroleum gas, also called as LPG, all burn with a flame. A flame is produced when a gaseous substance burns. Cooking gas, that is LPG, is a gaseous substance, therefore it burns with a flame. Petrol, ethanol are liquids, but on heating form vapors which burn with a flame. A candle is made of solid paraffin wax, which is a saturated hydrocarbon of high molecular mass. On burning the wick of a candle, the paraffin wax gets converted into its vapors. These wax vapors then burn with a flame. Any solid, liquid or gaseous fuel which produces vapors will burn with a flame. Coal and wood are also solid fuels, but they do not burn to give flame. They just glow red. It is because coal and wood do not form volatile vapors which can burn to give a flame. All solid fuels which do not form vapors will not burn with a flame. Sometimes coal and wood on ignition initially produce a flame. Initially, when coal or wood is ignited, the small amount of volatile matter present in coal and wood burns to give a flame. When there is no more volatile matter left in coal or wood, it just glows red without producing a flame. Why do we sometimes see yellow flame and sometimes blue flame? Incomplete combustion of fuel vapors produces a yellow flame. Yellow flame indicates that the combustion is incomplete due to insufficient supply of oxygen. The unburnt carbon particles glow to produce yellow flame. Yellow flame is always associated with unburnt carbon particles which form deposit of black soot. If there is complete combustion, that is, the combustion of fuel is carried out in sufficient supply of oxygen, a blue flame is observed. Blue flame indicates that all the carbon present in the fuel has burnt completely to form carbon dioxide. Which flame produces more heat energy? A blue flame or a yellow flame? Blue flame means complete combustion. No unburnt carbon particles are present. If the fuel is burnt completely, more heat energy is released. In yellow flame, a part of the fuel remains unburnt. Hence, yellow flame will release less energy, that is, it will be cooler. Formation of coal and petroleum. Let us learn about the formation of coal. Millions of years ago, most of the earth crust was covered with dense forests and swamps. As plants died, they were gradually covered by mud and sand in swamps. High pressure and heat acted on this partially decayed plant material over a long period of time and converted them into black solid called coal. As coal contains mainly carbon, the slow process of conversion of dead vegetation into coal is called carbonization. Coal is a mixture of carbon, hydrocarbons and other compounds. Since it is formed from the remains of vegetation, coal is also called as fossil fuel. Common varieties of coal include peat, lignite, that is a soft coal, bituminous, also known as household coal, and anthracite, known as hard coal. Each step during the carbonization process of wood to peat and from peat to lignite and from lignite to bituminous to anthracite coal leads to an increase in carbon content in the carbonization process. Let us now learn about the formation of natural gas and petroleum. Petroleum formation started in the prehistoric times. Algae, bacteria, and other microorganisms after dying sank from the surface layers to the bottom of the sea. Sand, carbonate sediments and clay transported by the rivers together with the minute organisms formed a deposit of organic silt. Over the years, the organic silt was buried under layers of sediments and under the combined action of heat and pressure was converted to oil and gas. Burial squeezed the oil and the gas out of the rocks in which they were formed towards low pressure area until layers of impermeable rocks stopped the flow. Reservoirs are formed only where oil-bearing rocks are capped with an impermeable layer of salt. Oxidation reactions. Carbon compounds like ethanol, that is C2H5OH, can be oxidized with an alkaline solution of potassium permanganate, that is KMnO4, or with an acidified solution of potassium dichromate, that is K2Cr2O7. The product of oxidation of ethanol is ethanoic acid, that is CH3COOH. To oxidize ethanol of ethanoic acid with an alkaline solution of potassium permanganate. The oxidation reaction of ethanol to ethanoic acid can be represented as shown on screen. Ethanol reacts with nascent oxygen on being heated to form ethanoic acid and water. Here, alkaline solution of KMnO4 acts as oxidizing agent. An oxidizing agent supplies nascent oxygen atom. The conversion of ethanol to ethanoic acid by alkaline KMnO4 solution is called oxidation reaction because ethanol takes up oxygen atom. Observe that the final product has more number of oxygen atoms than the reactant. Let us perform an activity to understand it better. For this, we take 1 to 2 ml of ethanol in a test tube. We next add 5% solution of potassium permanganate solution dropwise till the purple color persists. What do we observe? Potassium permanganate solution is purple in color. When it is added to ethanol solution, pink color disappears. On adding excess potassium permanganate solution, the purple color persists. We infer that alkaline solution of potassium permanganate is used up to oxidize ethanol to ethanoic acid. Now, if we warm the contents of the test tube for 10 to 15 minutes on a boiling water bath, we find the smell of vinegar comes out from the test tube. This means that ethanoic acid has been formed. The oxidation of ethanol to ethanoic acid can be carried out by heating ethanol with acidified potassium dichromate solution. Addition reaction. Unsaturated hydrocarbons contain less number of hydrogen atoms in comparison to saturated hydrocarbons. For example, the formula of ethane is C2H6 and ethene is C2H4. Unsaturated hydrocarbons can add hydrogen in the presence of heated catalysts like nickel or palladium to form saturated hydrocarbon. In these reactions, the double bond is the active site where hydrogen atoms are added. Nickel or palladium catalysts are used to speed up the addition of hydrogen to unsaturated compounds. nickel or palladium catalyst is not used up in the reaction. They are used only in small quantities and can be recovered back when the addition reaction is complete. The addition of hydrogen to unsaturated carbon compounds has a well-known application: hydrogenation of vegetable oils to vegetable ghee or solid fat. Vegetable oil contains long, unsaturated carbon chains. It means vegetable oils contain number of double bonds. Double bonds present in vegetable oil can add up hydrogen atoms to form saturated fat. Saturated fat, that is ghee, is solid and does not contain double bonds. The process of making solid chocolates, which are nothing but sugar-coated saturated fats, is done by hydrogenation of liquid vegetable oils. Nowadays, doctors recommend that unsaturated vegetable oils are good for health in comparison to saturated fats like ghee. Substitution reactions. Saturated hydrocarbons are quite unreactive. They do not react with acids, alkalis, and most other reagents. However, in the presence of sunlight, chlorine reacts quickly with hydrocarbons and chlorine atom replaces a hydrogen atom of the hydrocarbon. Similarly, second hydrogen atom, third hydrogen atoms, or fourth hydrogen atom can also be replaced by chlorine atoms. The reaction in which hydrogen atom of the saturated hydrocarbons is replaced by halogen chlorine atoms is called substitution reaction. Unsaturated hydrocarbon, however, add an halogen to form saturated chlorocompounds, that is addition reactions. Homologous series of chloroalkanes. The general formula is CnH2n+1Cl, where N is the number of carbon atoms. The difference in the formulae of two successive members of homologous series is CH2. The physical properties like melting and boiling points of the members of the homologous series increase in the number of carbon atoms. The chemical properties of chloroalkanes are similar because all the members have the same chlorofunctional group. Chloromethane has formula CH3Cl. Chloroethane has formula C2H5Cl. Chloropropane has formula C3H7Cl. Chlorobutane has formula C4H9Cl.